All right, welcome everybody. Today's lesson is acceleration for Physics Science 10. Last week, we talked about if a mass or person or a car or a jet or whatever travels a distance of 300 meters and it took that object 3 seconds, then if they go at constant velocity or constant speed, they would travel 100 meters in the first second, then 100 meters in the second second, and another 100 meter in that third second, for a grand total of 300 meters and 3 seconds. And then we took the formula V equals D over T to say that 300 meters, which is a distance, divided by the total time, 3 seconds, gives us a constant velocity of 100 meter per second. So this would be called the constant velocity formula, constant velocity, but and it would be drawn as such, where the person did exactly 100 meters, 100 meters, and 100 meters. But this formula could also go for the average velocity. So constant velocity, but it's also the formula for average velocity. In its simple form, it is, in the sense that if the same object instead traveled 80 meters, and then traveled 150 meters. So the first second, 80 meters, the second 150 meters, and the last second, 70 meters. Then we would use the same formula. The grand total here is 300 meters, and the grand total here is 3 seconds, and we would get that the average velocity would be 300 divided by 3 seconds, 300 meter by 300 seconds, which is 100 meter per second. So the constant velocity and the average velocity at this point are the same formula. Okay, this is a review. All right. So this week, we're going to talk about acceleration. Let's first understand what that idea is. What does one person mean when they say that they accelerate? What does it mean to accelerate? Right? If I go at 10 meters per second, when I start, if I accelerate, what does that mean? Does that mean that my speed is no longer 10 meters per second if I accelerate? Right? If I accelerate, that means I'm trying to go faster, or I'm going faster. So that's the idea. If I want to know by how much a person accelerated, if they went from this spot, A, to B, and their speed was always 10 meters per second, and I ask you, how much did they accelerate? You're going to say 0. They didn't accelerate at all. And you would be right. So clearly, we're not going to work with only one speed. We're going to have to work with 2 speeds. Right. So if the person went from 10 meters per second, and after a certain amount of time, say 4 seconds, right, they are now at 20 meters per second. Again, not 20 meters. Not a distance, but 20 meters per second. That's a speed. That's how fast they go. Right? Vroom, vroom. So basically, that speed increased by how much? So their initial speed increased by 10 meters per second in order to go from there to there. So we call this, I'll remove the letters now, and we call this the initial and the final situation. This is the initial situation, and this is the final situation. So the speed initially was 10 meters per second. The speed at the end will be 20 meters per second. We have to distinguish them because now they're both using the same letter, v and v. They're both velocities. So in physics, when we have the same units, we use the same letter. But this is going to be vi for initial, and this is going to be vf for final. I can try this. I don't know. I'm just trying something. Okay. So let's think about the acceleration. So say that I increased my velocity by 10 meters per second, which is what happened, right? Now we can talk about acceleration. So that's an increase by 10 meters per second. And we can say, well, so they increase 10 meters per second. So imagine it takes me a day, okay, to increase my speed by 10 meters per second, or maybe it takes you 1 second to increase your acceleration by 10 meters per second, or to increase your speed. What if it took me 2 seconds to increase my speed? Right? So again, I'm going from 10 meters per second to 20 meters per second. How long does that take me to do that? If it takes me 1 second, I'm accelerating very fast. If it takes me 2 seconds, I'm accelerating twice as slow, or twice as, or half as fast. Right? So 10 meters per second, 20 meters per second. After 1 second, what's my speed going to be? Right? So this is just a simple increase. My speed would be 15 meters per second. And after another second, it would be 20 meters per second. Or maybe it took you 4 seconds to increase your speed from 10 to 20. So again, this is going to be a constant acceleration, no change. So after 1 second, after 1 second, after 1 second, after 1 second, I want to know where we are. So 10 meters per second to 20 meters per second. I pass through 15 meters per second, which will be the middle part. So this, after 1 second, I would be at what? What's half of that? That's 12.5. And here it's 17.5. Right? So basically, you can see my speed increase from 10 to 12.5 to 15 to 17.5 to 20. By how much is it increasing? Okay, so let's try and use the formula here to see that. If I divide my increase by 4 seconds, then my acceleration becomes plus 2.5 and divide by 4, and the units, meter per second. And we can clearly see that's what's happening here. After 1 second, my speed increased from 10 to 12.5, right? You can see that it's increasing at that rate. And then after another second, it's going to go from 12.5 to 15, and 15 to 17.5, and then 17.5 to 20. Can't see. See? And that took 1 second every time. Not the best drawing, but hopefully it's transmitting some ideas. Okay, so basically that rate is kind of really important. This is the question that we're asking. What is the acceleration value? Okay, let's make a formula out of this. So if this is giving us the right kind of values that we're looking for, then what is this? What is this formula? Let's see. Let's go back up. So what was 10? How did we get plus 10? We got plus 10 because of this plus 10, which is the difference between the two. And how do you get this plus 10? You got VF and you took out VI, right? So this is VF minus VI, right? This is 20 minus 10. 20 minus 10 will give you 10. So this is what we're going to put in our formula. Oops. Okay. So this is what we're going to put in our formula. Acceleration will be VF minus VI. So the 20 minus the 10 will give us the 10 that we were, the positive 10 that we were working with. And then we divide it by the time that it took, right, to accelerate. So this part here is going to be the difference. Can you see that? Difference in velocity. This is, or we can also call this delta V. Delta V. Delta is the triangle, and it always means the difference. It has to do with triangle, but it's and it doesn't have to do with triangles, but it always means the difference. So the same way that the time is actually delta time, right? The time is from 4 seconds to 0 seconds. Time. And this part right here is the acceleration. I'm just trying to see what you guys can see and not see. Okay. Okay, so this is going to be the new formula. Let's use it with example 0. Example 0 is the simplest example I can think of. Imagine that the initial velocity, what we call at rest, 0 meter per second. So the person literally doesn't move. Wants to end up with a velocity of 4 meter per second, which is 4 meter every second. So 4, 4, and 4, right? So there's 4 meter every second. And let's say that they want to take 4 seconds to reach that speed, right? And then what's the acceleration? So we'll take the acceleration formula. So you write your information like we did before. That allows you to say VI, VF, T, A. You're looking in your formulas. You have about 20 formulas. This is the one that you target because it has the same values that you have. VF. Yeah, I can see that. I'm gonna have to fix my OBS. So the acceleration here would be 4 meter per second minus, I'm putting the units just as an example. Zero meter per second divided by 4 seconds. So minus 0 means nothing. So 4 meter per second divided by 4 seconds. The person will take 1 meter per second per second. So basically it's a positive number, so that means it's positively accelerating. It's going from a small value of the initial speed, like 0, and going to a higher value of 4. And it can only go and do that if it has a positive value for its acceleration. And we're also going to take a second to understand meter per second divided by second. Okay, so what does that mean, right? So in math, I'm going to try and write a little more centered. So in math, so this is meter per second, which is this, right? In math, you know that second can be over 1, or anything is over 1. Everything is over 1. And then when you divide by a fraction like this, you're allowed to multiply with the opposite. You get meter per second times 1 over second. And then what are you supposed to do with this? When you time two fractions, you multiply both tops and bottom, right? Top, bottom, bottom. So 1 times m is m, and s times s is s squared. So these are the real units for acceleration. Okay, we're going to go back here and we're going to write, so the plus, we can forget about it. It still means something. And we have the 1 and then the meter per second per second. We're going to start saying meter per second square. So that's meter per second square. Okay. And I'm going to bring this here. And we're going to go back to the 100 and continue. I'm just going to do this for fun. Okay, so the problems. What's going on? John Jovi is a truck driver. He wants to accelerate his truck so that its speed increase from 10 meters per second to 25 meters per second in 4 seconds. Number 1. So let's take the information from the paper and bring it on our paper, so we don't have to keep looking at 2 different places all the time, okay? So number 1, its speed increases from 10 meters per second to 25 meters per second. These are 2 speeds. As soon as you have 2 speeds, you're probably not going to be using this formula, because there's only 1 speed, and that's for a constant velocity. Clearly, this is not a constant velocity if it's changing. So which one is initial, which one is final? That's your decision to make. Well, they said, we have to look at the English. From 10 meters per second to 25 meters per second. So from, that's the initial speed, VI, and to 25 meters per second is the final speed, VF. So we need to not, we need to interpret it right to get the right values. How much time? Took 4 seconds. What is its acceleration going to be? There you go. So now that we have our problem, we can forget about the text. We can focus on the problem. VI, VF, T, and A. Which formula does that includes all of these information, or at least A? So we have A equals VF minus VI over time. Okay. And now we can start replacing. You don't need to put the units in. I don't need to see that. Like this, I don't need to. Okay, so we end up with 25 minus 10, so an increase of 15. I'm going to put the units just to review our units. And it took them a positive 4 seconds to do so. So the acceleration, as you can see, plus divided by plus remains plus, so it's a positive acceleration. 15 divided by 4 is 3.75. And the units just follow along. Meter per second per second. In our case, we understand that it's just an example. So then the final answer, so you could skip that part. The plus doesn't need to be there. We know what it is. It's a positive value. 3.75 meter per second square. And that's going to be the final answer. Okay, you could basically go almost from here to here. You should take a second to go to that step. You don't have to put the plus if you don't want to put the plus. You don't have to put the units if you don't want to put the units. Get 15 by 4. 15 by 4 is 375, but don't forget the units. And I think I'm going to clean it up for you. Okay. Acceleration. And that makes sense. Like, again, if we take a second to understand what happened, the initial speed was 10. They went from 10. Let's make a little drawing board. Time and velocity. At 0 seconds, the velocity was 10. After 1 second, what was the velocity? So if this means an increase by 3.75 meter per second every second, then after the first second, the speed increased by 375. So he's at 1375 meter per second. Right? These are meter per second after second. After another second, the speed increased by 375. So they're at 17.5 meter per second. After another second, their speed increased by 375 again. They're at 2125. After another second, their speed is increased to 25 meter per second. And you can see here every time it's adding plus 375. And it took them 4 seconds. So we can see this is the VI. You can see that this is the VF. And this is the total amount of time. Right? Are you getting it? Are you getting it? Number 2. Mary believes that if she can run faster than Rudy, she can place first in the competition. She accelerates and changes her speed from VI, 7 meters per second, to VF, 28 meters per second, in 12 seconds. Time, 12 seconds. What is her acceleration during that time? Sorry, I'm just going to show you that I'm working with this problem. I'm sorry. I'd like to read with you. Okay. Yes, yes. Yes. Mm-hmm. 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 No. Okay. What's the formula for acceleration? VF minus VI over time. Let's put everything in. This is the simpler way. 28 minus 7 over time, 12. Acceleration is 21 over 12, which can be simplified to 7 over 4. You divide by 3, right? The acceleration, so 7 over 4, again, 7 divided by 4 is 1 point, right? So 4 goes into 7 once, you're left with 3/4, 1.75. Now the units, it's an acceleration, meter per second square. Okay, and that's the solution. So as you can see here, if she has 12 whole seconds, if she has 12 whole seconds, and every second she increases her speed by 175, that's almost 2 meters per second every second. So her speed goes from 7 to 9 to 11 to 13 to 15 to 17 to 19 to 21. You know, it gets to 28 in 12 seconds, right? And that's the rate at which the speed increases every second. You'll also notice that it's a positive value. It's a positive 1.75. So it's increasing from a lower number to a higher number. Let's do a different problem, number 3. This is the last problem I'll do with you, and we'll get a new formula out of it. I'll put it on the paper. Mary accelerates again, but this time at a rate of 3 meters per second square for 4 seconds. They give us the acceleration. By they, I mean me. I give you the acceleration. The time is 4 seconds. Her initial speed, VI, is 5 meters per second. What is going to be her final speed? So we're asking VF will be equal to what? Right. So let's take again our formula. So the formula that includes A, T, VI, and F, VF, is A equals VF minus VI over time. So in 9th grade, what you're allowed to do is directly replace without moving anything, because the real question is this, right? So in 9th grade, you can put everything in. You don't have to change anything, move anything, I mean. In 10th grade, we would probably ask you to move things around. And I will do that once, and we'll end up with a new formula, which will be faster. Let's do the 9th grade kind of physics here. So A is 3 meters per second square. VF is unknown, so it stays VF, minus VI is right here. VI is 5. And we're going to divide that by the time, which is 4 seconds. Great, so now we have a math problem, basically. So the math problem is to find VF, or to isolate VF, or to focus VF. So what are we allowed to do here? I'll try to stay in the frame, but we'll see what it gives. So what are we allowed to do? So VF minus 5 is kind of one thing, and then that thing is divided by 4. So we should start by getting rid of the divide by 4, because it's the last thing that will happen. So let's take care of it first. Remember, BEDMAS in reverse. We're doing BEDMAS in reverse. We're going to take care of this divide by 4 first, because it's being applied on everything. So what's the opposite of divide by 4? It is times 4. I'll also note here that 4 is actually the time, right? 4 is the time. So I'll say We're actually doing times t. And I'll come back to that in a second. Because I want you to see that we're not doing that much difference in Math 9 and 10. So we're going to time by 4 both sides. So let's do that. 3 times 4 is going to be equal to VF minus 5 over 4 times 4. So we have this thing here, times 4. Or we can also say we have this thing here, times 4 divided by 4. So times 4 divided by 4 goes away. We're left with 12 is equal to VF minus 5. So again, we want VF. We don't want minus 5. So what are we allowed to do? On both sides, plus 5. You'll notice also here that plus 5 is VI. So I'm actually adding VI. I'll put that as a note. Plus VI. You'll see why. Okay, let's do plus 5. 12 plus 5 is equal to VF minus 5 plus 5. All I did was add 5 here on both sides. I didn't do anything. All right. We end up with 17 is equal to, and here this and this cancels out, VF. Or can't really leave that like this because it has no units and it's upside down. So VF is 17 what? So velocity is meter per second. So this is the final answer. So we found the answer using the math, the physics formula, and the math, the proper math operation. Good, reasonable, acceptable, I believe. We're gonna look into, let me do this here. So what we're gonna do now is we're gonna do the same problem, but this time we're not gonna put the numbers first. Let's go back here. Let's write our formula again. A is VF minus VI over T. And this time we're going to isolate VF without putting any numbers in. We're going to leave the letters as they are. And this is algebra, right? So this was arithmetics. What we did here was arithmetics. The same laws for arithmetics apply to algebra. And I'm going to keep an eye on this side here, because that's exactly what we're going to do. So if we want to isolate VF, and we have VF minus VI is then divided by T, divided by T is the last thing, so that's what the first thing we're going to take care of. So what's the opposite of divide by T? Multiply by T. Okay, so let's do that. A times T equals VF minus VI over T times T. So again, you can say this is times T, but that would be good enough to cancel them. You can also say that all of this is time T and then divided by T, which is also good again. So T's cancel out. We're left with AT equals VF minus VI. We're almost there. So we don't want minus VI. What's the opposite of minus VI? Can you see that? Plus VI, which is exactly what we did. We did those operations before. So let's do that. Let's do plus VI. All I'm doing is doing it with the letters instead of the numbers. So AT plus VI stays like this. And then VF minus VI plus VI, right? So again, I'm just adding VI on both sides, canceling out the VIs, leaving us with this part. Can I rewrite this as this here? I'm moving this over there. And I'm moving all of this over there. AT plus VI. This is interesting. It's basically saying, imagine that your speed is 5. And to that, you add your acceleration, which is 3 meters per second. And because you increased by 3 meters per second every second, you did that for 4 seconds. Then you're going to add 12 to 5 and get 17, which is our answer. I'm going too fast. Okay. Let's rewrite this another way. So VI plus AT. And let's just look at this. This is basically saying I'm going to take my initial speed and add the acceleration rate times the time that I've allowed myself to accelerate. So if I accelerate by 1 meter per second, and I allow myself 4 seconds to do that, then I've increased my speed by 4 meters per second, right? If I allow it to happen for 8 seconds, then basically I have 1 meter per second square times 8, which is going to be an increase of 8 meters per second. So if my initial speed was 4, and I add 8 to that, my final speed will be 12, right? 4 plus the 8 of change, the 4 meters per second and the 8 of increased velocity due to the acceleration and how long I've accelerated for at that rate. So I like this formula a lot because it makes it very kind of clear. You take the initial acceleration, the initial velocity of 4, you say you accelerate at 1 meter per second for a whole 3 seconds, so your new speed will be 7 meters per second. Because you accelerate at 1 meter per second for 3 seconds. In our case, okay, so this formula, I've added it here in the document. VF is AT plus VI. Doesn't matter which way VI or AT is. Basically, if you use that formula instead, because you're looking for VF, your VI is 5 meters per second. And you're adding a rate of 3 meters per second square times 4 seconds. So let's look at the units to see what's happening. So 5 meters per second plus, so 3 times 4, right? So you can put that in bubbles. Right? So 3 times 4 is 12. Then let's put the units together. We have meter times seconds divided by seconds squared. So the seconds cancel out with one of the seconds, and you're left with meters per second. And you're adding meters per second to meters per second, which is good. This is what it needs to be, right? We can't have a situation where you have 4 meters per second plus 1 second. This is not a situation that makes any sense, right? You can't add a second to a velocity, a time to a velocity. If you want to add a velocity to another velocity, you can, right? And end up with a velocity. But you can't add a velocity and a time. This doesn't make sense. So the units, basically the units tell us if we're doing our math right. And because we end up with meter per second and meter per second, you know our math is right. So VF is going to be 5 plus 12, 17. 17 what? Meters per second. As you can see with this formula, it's much faster because the focus is already ready. We did the math for you, or the math has been done prior to. Okay, so we learned the math and the algebra to work our formula in physics, and then take the formula, especially physics 11 and 12. You then take the focused formula, put your numbers in, and get the answer, right? That's going to be it for that. I did put other numbers down here that have, you know, how much time will things take. Right, this is harder. So if we do number 9, 4 meters per second, from 4 meters per second to 22 meters per second. So that's VI and VF. With an acceleration of 4 meters per second square. How much time would that take? We can take our formula, VF minus VI. You should always write your formula down. All right, so you have one sheet for the problem, one sheet for the formula, and then you can start working. 4 meters per second square is equal to 22 minus 4 over t. So 4 is equal to 18 over time. And now what? How do you get rid of the divide by t again? By this time, I hope that you understand that you can have a t at the bottom of the equation. Have to get it out of there by any means necessary. So instead of divide by t, we're going to times by t. You see how you have to time by t anyway? You're kind of stuck. You have to do algebra. So 4 times t is 4t. And 18 divided by t times t. Right? 18 divided by t times t. Cancel out. Basically 4t equals 18. You don't want 4t, you want to divide both sides by 4. Right, so I'm dividing by 4. You don't need to write this. This is a note. This is my note. 4 and 4 go away. You're left with t equals 4.5. Because it's your answer, you should write your units, seconds. That's it. So it's not too bad, not too hard. I hope that these examples are good enough for you today. And this is pretty much the last things we're going to do in science. So I encourage you to try it. Acceleration is a very big concept in physics. If you like physics, get good with it. Number 7, the initial speed is 30 meters per second. The final speed is 5. So you're going really fast and then you're slowing down. But if you keep VI as 30 and VF as 5, as you should, then you're going to end up with a formula like this. VF is 5 minus VI, which is 30. And that's okay. It means the minus 25 divided by the time means that the minus here means it's a deceleration. So that's why I called it a deceleration. So decelerating is going from a higher number to a lower number. So your acceleration will be negative. Besides that, that's pretty much it.